talked about converting between degrees and radians, and of course, radians to degrees. We also talked about degrees, minutes, seconds, and we also used unit conversions. And those were the really, really long ones with multiple fractions where we needed the units to cancel out. That is where we want to start today. Okay, if you don't already have your notes out from Thursday where we talked through different conversions like minutes to hour, inches to feet, feet in a mile, radius versus radian, revolution, all of that kind of stuff, let's go ahead and make sure that you have those out now. We should be in the process of memorizing those, but I'll give you some grace today. So again, today we are going to really concentrate on those unit conversions. The one that you've already seen is when we went from rotations per minute and we wanted to go from miles per hour. This time I'm going to change up the problem on you a little bit, and it's going to be a construction. In particular, we're going to talk about circular saws. So on this circular saw, it is going to have a blade with a diameter of 10 inches and spin at a rate of 2,000 rotation per minute. So we're going to have 12 cutting teeth per inch on the cutting blade. So I want to know how many times do the teeth cross that surface each second. So I've got Chip Gaines here from Fixer Upper to help us out. So we are going to be going back and forth from a rotation per minute to teeth per second. So we are going to have to convert time and length. So my time is going to go from minutes to seconds, which that one probably is not very daunting. And our length is going to go from rotations to the amount of teeth. That one can give you a little bit of struggle. Remember, this is going to end up looking like a series of fractions where we're going to have a unit in the numerator and the denominator, and they should cancel. So we're going to start off with 2,000 rotations per 1 minute. Now that rotation and the minute, that is very, very important that you're writing that in there because that's what we're looking at to cancel. So because I think the time is going to be the simpler one, that's where I'm going to start. So I've got 1 minute has 60 seconds in it. So now my minutes are going to cancel, which is what we needed, and seconds is actually what we want the answer to be in. So just like that, we've done half of the conversion. Now I've got to go from rotation to teeth. This is when looking back at the notes from Thursday are going to help. So one rotation is actually 2 pi radians. So that's one full circle. So now my rotations are going to cancel, but I'm still not at teeth. But I do know that 1 radian is also 1 radius. What's going to be a little bit tricky this first couple weeks is getting used to the idea of rotations, talking them in terms of radians. Radians is going to be a vocabulary term that you're going to have to get fluent with. Now, we do need to be particularly careful about diameter versus radius. So this problem gives me a diameter, which I don't need, but all I have to do is cut it in half to find the radius. Last piece, I have 12 cutting teeth per 1 inch. So I'm going to make sure that I have an inch in numerator and denominator so I can cancel them out. Then it ends up with teeth. So now I have the final 2 units that I need, seconds and teeth. So from here, I'm now going to rewrite my fraction without all of the units so I can compute them. So I've got 2,000 times 1 times 2 pi times 5 times 12. Now make sure when you put this in your calculator, actually use the pi button and not 3.14. When you compute that, you should get 753,982.2369. Personally, I like to wait till around to the very, very end in case some weird things happen. Then the denominator, 1 times 60 times 1 times 1 times 1. Lots of identity properties in there, so that just gives me 60. When I divide all of that out, that's going to give me 12,566.37 teeth per second. Units are going to be very important here, so make sure that you're leaving the units in your answer. If you get stuck in these problems, the best thing for you to ask yourself is, what do I have and how can I manipulate it based on the conversions that Miss Smith and Mr. Wicks have told me that I need to know? If from there you are still stuck, please ask. We are here and we want to help you. So now it's your turn. All right, now remember this year in particularly, we are going to hashtag own our learning. So if you need help, you've got to ask for it. I would love to help you. Mr. Wiggs would love to help you, but we don't know unless you ask. So as we move forward, we're actually going to go backwards in time to your sophomore year. You are either cheering or crying. I really hope it's cheering. But we're going to talk about special right triangles. There are two of them. There are 45, 45, 90 and 30, 60, 90, right? So clearly these are right triangles, so you're gonna have to have a 90-degree angle. Those other numbers, 45, 30, and 60, are talking about the other degrees inside the triangles. Guys, you may not remember them right this minute, but this is gonna be one of those things where you have to own your learning, and if you don't know them now, you've got to figure them out. Here they are, okay? So 45, 45, 90, 30, 60, 90. So we have x's here. Those x's are representative of integers. So I could put a 1 here. So I could have 1, 1 in root 2, or I could have 2, 2, 2 root 2, so forth. And when I go to name this 45, 45, 90, or not really name, but to identify, I could use only one 45, then you would know this one is 45, or I could say, hey, this bad boy is isosceles. Okay, when you go to look at 30, 60, 90s, we've got x, root 3x, and 2x. So for instance, if this is 1, it would be 1, root 3, and 2, or 2, 2 root 3, 4. Sorry for all that movement. So now we're going to have to practice this. I'm going to go through 4 with you before you practice on your own. Okay, so the first thing I want you to do when you're looking at these problems is identify it. Is it a 30, 60, 90, or is it a 45, 45, 90? Okay, because from there, you should be able to label the triangle and then move forward. You do need to get to a place, though, where you can skip some of these steps and do them in your head. So number 1 is a 30, 60, 90. So I'm gonna add the 30-degree angle in there and draw an arrow to the number across. That is going to be what you would, your normal side, or the side that you manipulate, that's going to be your x. So the hypotenuse is going to be whatever that number is times 2. Then I've got to take whatever that number is and multiply it times root 3. Right? So in this particular problem, x is equal to 8. Y is equal to 4 root 3. These are just formulas, or you can consider them like vocabulary. The more you practice them, the more fluid they are going to become. Shifting to number 2. This one's a 45, 45, 90. So the sides that are across from the 45-degree angles have to be congruent, or they're going to be the same. I know that one of them is 6, so that means the other one has to be 6. Then to find the hypotenuse, I'm just going to attach a root 2 to it. So for this particular problem, x is equal to 6 root 2, y is equal to 6. Full disclosure, numbers 1 and 2, I would consider about a level 1, pretty basic, do you just know the formula problems. Once we hit to 3 and 4, these are going to get a little bit more fun. So number 3 is a 30, 60, 90 again. I'm going to take the same approach, where I'm going to draw an arrow across from the 30, and that's where my angle should start. So then I would take that b to multiply it by 2 to find the hypotenuse, and I would do b times root 3 is equal to the side across from 60. Since that's my actual numeric value, I'm going to set that equation up to find b. So I've got root 15 is equal to b times root 3. Divide both sides by root 3, and I get root 5 is equal to b. So now I know b. So to find a, I have to multiply it by 2. So that's going to give me 2 root 5. So a is equal to 2 root 5. B is equal to root 5. That one is a little bit more challenging because of the dividing with roots piece. Number 4, we've got a 45, 45, 90, says isosceles. X and y are the same, and they happen to be what I'm looking for. But I know that all I have to do is take my x and attach a root 2 to it, and that's my hypotenuse. So now I've got x root 2 is equal to 3. To get that x by itself, I'm going to divide by root 2. The problem, you cannot have a root in the bottom of a fraction. Ever. So I'm going to multiply the top and bottom by root 2 times root 2, because that's technically 1. Multiply straight across. Root 2 times root 2 is root 4. The square root of 4 is 2, or you could just go straight from root 2 times root 2 is equal to 2. So x is equal to y, which is equal to 3 root 2 over 2. Guys, I went through that really fast. really fast. So if you're swimming a little bit, that's okay. What I would do if I were you is put your pencil down, rewind this, just watch examples 1, 2, 3, and 4 first, then try the problems you're going to see in 3, 2, 1.